Hello, in this video we are going to pick up where we left off and continue our implementation of the RPGStat system. In the previous video, we stopped after finishing the implementation of the abstract class SimpleStat. And today we will start by implementing various concrete implementations of this class. The first and the most simple one is going to be called SimpleStatAdd. And as you might gather from the name, it will be a stat that simply adds the values of the modifiers together. Since this class is not abstract, we should also make a constructor for it, and we can just call the base constructor. The functions that we need to implement for this class are going to be the add operation, remove operation, and set base value abstract methods. You may remember in one of the previous videos, if I'm not mistaken, it would have been video number 2, we talked about how the implementation for the new system tries to keep stat calculations to a single math operation at the point of adding and removing modifiers. With that in mind, the implementation for our add operation here is just going to be adding the value of the modifier to the current value of the stat, and for the remove operation, we're just going to be subtracting the value of the modifier. And for the set base value function, we combine both a subtraction and an addition, but this time, since we're not handling any modifiers, we subtract the old base value and we just add the new base value. And for this particular implementation, all of these functions return false, since there's no need to set the stat as dirty, given that all of the calculations that we needed have already been fully done here. The next stat that we need to implement is going to be SimpleStatMult, and once again, from the name, you'll be able to tell that this stat will multiply modifiers together. You may naively think that copying the SimpleStatAdd implementation and simply changing the additions to multiplications and the subtractions to divisions would be sufficient to implement this. That is unfortunately not the case. And the reason for that is that when it comes to multiplications and divisions, 0 is a special number. If you add a modifier that has a value of 0, the value of the stat becomes 0 as well. If you then remove that modifier, you can simply divide everything by 0 again to get the value that you had before. However, since we know that 0 is special, we can also create special cases to handle. So what we're going to do instead is we will cache the number of modifiers with a value 0 that we currently have in the stat, and we will store the last known value that isn't 0. So our add operation becomes the following. We will check if the value that we are adding is 0. If it is, we don't do any multiplications, we just increment our zeros count. If it isn't 0, we can proceed with the calculation as normal, but instead of using the stat's current value, we will use our non-zero value that we saved. In the end, we will assign to the new value of the stat the following result. If our zeros count is bigger than 0, which means at least one modifier is 0, the final value of the stat has to be 0. If we have no zeros, then we can use our non-zero value variable and assign that instead. For the remove operation, we are going to do basically the same thing, but in reverse. If the value we are modifying is 0, we don't do any divisions, we just decrement the zeros count variable. If the value we're removing is not 0, we can safely divide our cached non-zero value, and then, by the end, we assign the new value using the exact same logic as the add operation. And for set base value, we are going to once again combine both the add and the remove operations into one. We will use the same logic we used in the previous functions to remove the old base value and then add the new one. You may have noticed something a little strange in the add and remove operations, where I'm not using the modifier's value directly. Instead, I am adding 1 plus the modifier value and using that. And in order to understand why, let's take an example. Imagine two stats that are supposed to represent a percentual modifier. For one stat, you want the modifiers to stack additively. For example, if you add two 10% modifiers, you end up with a 20% increase. Take another stat where you actually want the modifiers to stack multiplicatively, which means if you add two 10% modifiers, you actually increase by 21%. In order for the math to work out, in the first case, your modifiers need to have the value 0.1. And in the second case, they actually need to have the value 1.1. So, in order for us to be able to use the exact same modifier values in both cases and it working as expected, instead I opted to add this 1 directly in the SimpleStat operation. This way, you can use two modifiers with the exact same values in both of these circumstances, and the result will be consistent. I've also made the default base value for this class to be 1 instead of 0, because for something that's supposed to multiply, multiplying by 0 by default seems a little bit counterproductive. Last but not least, since we are also taking into account base values for our zeros calculation, we should also take that into account in the constructor. The way that's gonna look is that if our initial base value is 0, then we will increment our zeros count to 1 right off the bat, and we will also store our non-zero value as simply being 1. Otherwise, our zeros count is 0, and our non-zero value will be the base value. There's just one last thing we need to do in this class to make this all work flawlessly. There's a couple of situations where we actually want, for these cached values that we are saving uniquely in this class, where we want to reset them. But we need to implement a virtual method in the base class in order to call that at the right times. This method will simply receive the base value, and we will call it in the clear method and in the getFinalValue method. For its implementation, we're just going to move the code that we are using in the constructor to this method, and then we can call this method from the constructor itself as well. We have two remaining stat implementations to go. Those will be SimpleStatMin and SimpleStatMax. The functionality for these will be a little different, where instead of simply accumulating a value in the stat, we actually want to figure out either the lowest value or the highest value out of all the modifiers. So unfortunately, these will have certain cases where we won't be able to simply calculate the final value outright from simply adding or removing a modifier. We might actually need to recalculate the whole thing, taking into account all the modifiers, and make use of the dirty flag. So for SimpleStatMin, we always want to take the lowest value, taking into account all the modifiers and the base value. So when adding a new modifier, we can simply check to see if that modifier is smaller than the current value, and apply that if it is. Otherwise, the current value remains the same. For removal, that's a different story, because we can't know for sure which value is the smallest out of all the other modifiers that we have. So whenever the value we are removing matches the current value, that means that there's the potential that the new lowest value will be something else. So in this case, we have to set the stat as dirty so that it can recalculate the correct value the next time it is requested. For setting the base value, just like in the other SimpleStats, we need to combine the logic of the two functions, where we remove the old base value and then we add the new one. And finally, for SimpleStatMax, we will just copy what we did in SimpleStatMin, changing the names and changing all of the less than signs to greater than signs. And we also change the default base value from float.max value to float.min value. At first glance, min and max stats may not seem very useful, but they were originally inspired by Baldur's Gate 3, which has many items that set your stats to a fixed value. In that game they are called ability scores. And also by games like V-Rising, which has a hard cap for many of your stats. By having the separation between min and max, that also allows you to implement other interesting things, like a stat that cannot go below a certain value, which you can do by modifying the min stat, or a stat with a hard cap, by modifying the max stat, or accomplish things like in Baldur's Gate, and set your stat to a specific value by setting both the min and max to the same value. That's all for the SimpleStat classes. In the next part, we will be implementing the regular stat class, which does not contain modifiers and instead contains other stats.